In a free radical polymerization, only that monomer are polymerized which contain carbon-carbon double bond in their repeat unit. For example, the polytetrafluoroethylene is polymerized by the free radical polymerization. Its monomer is the tetrafluoroethylene CF2. You can see here carbon-carbon double bond in their repeat unit. So example, option B is correct. Polyurethane is formed by the condensation polymerization of diisocyanate and polyols. Polyols provide flexibility in polyurethane and diisocyanate provide strength in the polyurethane. So diisocyanate and polyols is the monomer of the polyurethane PU and it is polymerized by the condensation polymerization. So option C is correct. In option A given that self condensation polymerization. First, understand what is the self-condensation polymerization. In a self-condensation polymerization, only one type of the monomer participated which contain two or more than two functional group, different functional group. For example, omega hydroxy caproic acid, OH. CH2 You can see this is the single type of monomer in which the two different type of functional group. One is the alcohol and second is the carboxylic group. So two different type of functional group available. So it is the polymerized by the self condensation polymerization. And this polymer is known as polycarbolactone (PCl). Polymer is the Markov-Markov compound which contains a large amount of the carbon atom in their repeat unit. And glass transition temperature. Glass transition temperature is the property of the amorphous region in polymer. And melting point is the property of the crystalline region. So, better understand, take this is the polymer, sample of the polymer in which this is the order structure. You can see here is the order structure, so this region is known as the crystalline region. And you can see there is the random arrangement of the molecules. This region is known as amorphous region. So the glass transition temperature is the property of the amorphous region. So you can see here is the large amount of the carbon atom available. So surrounding carbon atom surrounding 40 to the 60 carbon atom when start the vibration motion that show the glass transition temperature. The blend of polyvinyl chloride and polyacrylate have dipole-dipole interaction. Dipole interaction. Better understand by their structure, how they are combined. This is the polyvinyl chloride and this is the polyacrylate. You can see fluorine is also polar atom and CO is also come under the polar group. So these CO, the fluorine and this CO atom are the attracted to the each other and form secondary forces bond. So you can see there is no presence of the hydrogen bond. Yeah, any induced dipole, any induced, only the presence of the dipole interaction. Polytetrafluoroethylene polymer is known as non-polar polymer. How PTFE is the non-polar polymer better understand by their monomer. This is the monomer of polytetrafluoroethylene. So this carbon is also sp2 hybridized, and this also the sp2 hybridized. So this angle is 120 and 120. The fluorine is the highest electronegative in the periodic table. So the dipole moment direction in carbon atom to the fluorine atom. Here is the same, here is the same, and here is the same. You can see these both dipole moment is the opposite in direction, so these are the cancel out to each other, and similarly these both dipole moment are the opposite in direction, so cancel out to each other, and their polarity will be cancel out, so it comes under the non-polar compound. Here is the no presence of the hydrogen bond या any dipole interaction, so the PTFE is polytetrafluoroethylene is degraded before their melting point due to van der Waals. Here you can see that there is no hydrogen bond या dipole interaction, so the PTFE is degraded before their melting point due to van der Waals interaction. So option C is correct. The relationship between the polymer viscosity and polymer molecular weight is given by POS. M is the molecular weight of the polymer and MC is the critical molecular weight of polymer. So when molecular weight of the polymer M is the less than the critical molecular weight of the polymer, in that case the viscosity of the polymer is equal to neta is equal to KL into M के power 1. But when molecular weight of the polymer M is the greater than critical molecular weight of the polymer, in that case the viscosity of the polymer neta is equal to KH into M के power 3.4, where KL and KH are the constant. In given question, given that molecular weight of the polymer is the greater than critical molecular weight of the polymer, so this formula is applied. So the correct option is B. In step polymerization of the phenol with the formaldehyde, then the functionality of the phenol. What is the functionality of the phenol? Better understand the phenol. This is the phenol, and this is the formaldehyde. In the condensation polymerization, this formaldehyde attack on the this ortho position, also on this ortho position and on this para position. So the functionality of the phenol is 3. The polymer and their degradation method. The PBC is degraded by the elimination of the low molecular weight of compound like as HCl. The polyacrylate is degraded by the cyclization process, and polymethyl methacrylate PMA is the degraded by the unzipping process. And polyethylene is degraded by the random session. So the correct option is A. The solute dissolve in the solvent if the difference in their solubility parameter is less than 2. In the given question, the given that the solute is the polystyrene and their solubility parameter of the polystyrene is 9.1, and simply asked in which solvent it will be dissolved. By checking the option, only in option number D, given that benzene, the solubility parameter of the benzene, given that 9.2. When they taking the difference between these solubility parameter of the benzene minus solubility parameter of the polystyrene, 9.2 minus 9.1 is equal to 0.1, which is less than 2. So the polystyrene is dissolved in the benzene. So option D is correct. Polymer composite of the epoxy and glass fiber. So first understand the concept of the polymer composite when apply in unidirectional force. Yeah, take this is the glass fiber and this is the polymer composite surrounding the glass fiber. When apply the external forces on the polymer composite, then these forces distributed on the polymer matrix and on the glass fiber. You can see that when apply these forces, these forces is distributed on the polymer composite and glass fiber. So strain, when application of the forces, some strain produced in the polymer matrix and glass fiber. When some strain produced in the polymer matrix, take this is the extension in the and this is the extension in the glass fiber. Then first, when the extension in the glass fiber not equal to the extension of the polymer matrix, so the slippage will be occur. In that case, polymer composite will be failed. But for no slippage, the strain produced in the polymer matrix should be equal to strain produced in glass fiber. So strain produced in the polymer matrix should be equal to strain produced in the glass fiber for no degradation and no loss of the mechanical property of the polymer composite. So option C is correct. The power factor PF and dissipation factor DF both are the electrical property of the polymeric material. So the power factor PF is equal to cos theta and dissipation factor DF is equal to cot theta. So find the relationship between the power factor and dissipation factor. So dissipation factor is equal to cot theta. I know that cot theta is equal to cos theta divided by sin theta. Then dissipation factor is equal to cos theta divided by square root of sin square theta. With taking the square root of sin square theta, you get the sin theta. So you can note that cos square theta plus sin square theta is equal to 1. In that case, sin square theta is equal to 1 minus cos square theta. So dissipation factor is equal to cos theta divided by root of 1 minus cos square theta. क्योंकि cos theta is equal known as power factor. So dissipation factor is equal to power factor divided by root of 1 minus power factor का square. So this is the answer. The polymethyl methacrylate used in the making of the contact lenses due to their high transparency and transparency of the polymethyl methacrylate surrounding 92% and transparency of the polycarbonate surrounding 88% and transparency of the polystyrene surrounding less than 85% and transparency of the PET surrounding also less than 85%. Know this value. And silicon rubber. Used to the making for the tissue replacement, and also used in the making of the baby feeding nipple due to their high flexibility and high weathering resistance. So the silicone in the making of the tissue replacement and baby feeding nipple due to their high flexibility and weathering resistance. The graph between the polymer viscosity and shear rate of the polymer. Shear rate and neta represent the polymer viscosity. This is the graph between the viscosity and shear rate states of the polymer. For the better understand the concept used in the question number 15, take this is the parallel plate and flow in this. Fluid is flowing in this. This is the inlet and this is the outlet. You can this is the lower plate and this is the upper plate. Here the shear stress is low, but increasing the length, increasing the height, the shear rate will be increases. So at the low shear stress, shear rate, you can see the viscosity will be high. Low shear rate, viscosity will be high. But in case of at increasing the shear rate, viscosity of the polymer will be decreased. At high viscosity, at high shear rate, you can see the viscosity will be low. So the correct option is the viscosity. Viscosity simply represent neta या mu. So the viscosity at lower plate is the greater than viscosity at upper. This is answer. Fire retardant used to protect the polymer from the fire, and some typical example of the fire retardant is aluminum trioxide, antimony trioxide, antimony dioxide, chlorinated paraffin, chlorinated ether, brominated ether, and more on. Heat stabilizer. Heat stabilizer is used to protect the polymeric material from the heat. Some example of the heat stabilizer is tribasic lead sulfate, dibasic lead sulfate, acetous, and more on. Lubricant is used to reduce the friction between the polymeric material during the processing. The common example of the lubricant is the cetyl palmitate, calcium fluoride, boron nitride, tungsten disulfide, graphite. Graphite is the solid lubricant. Graphite and molybdenum disulfide is the solid lubricant, and more on. Filler. The main use of the filler to reduce the cost of the polymeric materials. Then some major example of the filler: calcium, barium sulfate, calcium carbonate, titanium dioxide, talc, mica, and soapstone, and more on. This is the use as the filler to reduce the cost of the polymeric material.